Lab 3, the game of anticipation, is really going to be our first development lab for the real-time systems course here. What we're actually going to do is build a little bit of a game that is going to be based upon the concepts we've talked about thus far in class, namely latency and getting a little bit with the idea of multi-threading in C++ using the C++ multi-threading libraries. So the game itself that we're going to build is pretty simple. Basically, what will happen is a light will turn on. When the user presses a button, it will indicate that the user has pressed it. And we're going to measure the time between when the light turned on and when they pressed the button. And we're going to measure that latency. And it's a little game between two players trying to see who's faster at making the game work. So what I have here is a developed version of the code here. And what I'm going to do is take my Raspberry Pi here, and you can see I have the Raspberry Pi cape here, and we're going to see, or excuse me, the Pi hat, not cape, excuse me. And what I'm going to do is I'm going to start this running as in a debug mode. And what happened is the cord came partially undone, I think. Hope that's what the problem was. There we are. So we are getting ready to debug. Here we are. We have just stopped at main. And I am just going to have the code continue running right now. We can see that we have all these threads running like so. And what will happen is I have green lights turned on both of them, so you can't see that real well. I'll press the button and make the red lights turn on, like so. And here we go. Usually this would be 2 players. And there we are. So we can see what the latency was on each time the button was pressed. So player 1, first time was 7,051 milliseconds, 75, so 7 seconds, 738, 438, like so, half second, so on and so forth, all in milliseconds. We sum all of those together, and then we say who is the winner based upon who had the least amount of time, and then the threads will exit. So that is the demonstration of the code at work. How is this code built? How is this code structured? Well, as I drag this over onto the screen here, we can see this is our GPIO board. And on our GPIO board here, we can see very carefully, if we look at them, D1, D2, D3, D4, D5. These are the names of the LED lights. And on our board over here on the right, we have information about which GPIO pin those are connected to. So we're going to need to use that information to figure out how to turn on the red or the green light accordingly based upon the problem we're trying to solve. The design of the software here is actually very straightforward. This library over here on the right, this SE39 RPI GPIO, this is provided to you. And you see you are going to be creating this game player class, implementing it here where you have these sets of attributes and these methods down here. You also will be implementing main, where main is basically going to spawn the threads up. So you're going to have a thread that will run basically the run method, like so, for each one of them. And you're going to have a constructor that's going to construct basically an instance of that class. For each player, so to speak, on it, which there's going to be 2 players in this when all is said. There's going to be an instantiation of a GPIO that's going to represent the green light, the red light, and the push button. So if we go back to that picture that we had up above here, this push button here would be associated with player 1, player 1, player 1, and this is going to be with player 2, player 2, player 2, like so. Those are going to be associated and tied together with each other and created inside of main. The threads will be spawned, and then main will block while these threads are running. When those 2 threads finish up, one for each one of the players, then main will go through and figure out, hey, who happened to be the player that had the least amount of time. So that's what the functionality is going to be as far as from a design standpoint. How are you going to figure out what all of these methods are supposed to do? Well, what you are provided with is a set of documentation for this. This is deoxygen generated, and what you could do is you can look at each of the classes. So if I wanted to know what GPIO was about, so if I wanted to look, for example, at the constructor, we can see the constructor, what the parameters mean, what the values are. All of this is documented. If I go into, for example, game player here, and I want to figure out what goes on in the run method, we can see the comments here generated automatically explaining what is going on in run. If I wanted to see what is going on inside of some of these other things or what these other attributes mean, I can look at them here. I can look at the constructor, for example, what the parameters mean. All of those kind of things are defined in the documentation that is provided to you. This is deoxygen generated. It's basically a set of browsable HTML files. Very, very similar to the browsable Java doc that you have been given in past examples of projects. The other thing that is given to you is this file called Hello World. Hello World, and here you can see obviously the documentation being created. I have given you full implementations of this particular file so that you can see kind of the mapping of how it gets generated. You also have the ability to look inside of this GPIO file to see what's going on as well, because it is fully documented and that is provided to you. So, all right, at this point in time, you've seen a demonstration of Lab 3. You've seen a little bit about how the design for Lab 3 works. You've seen some information here about how the Java, or the documentation, excuse me, not Java doc, how the deoxygen generated documentation is given to you. So I'm going to bring this demonstration video here to a conclusion.